Hello, everyone. Welcome to AWS Tech Talk. Today, we will cover how a US government agency accelerated its cloud migration to GovCloud. My name is Atul Mathur. I'm one of the principals here at Credence Management Solutions. I'm joined by Jonathan Trellis, Solution Architect with AWS, and Carlo Tedesco, Technical Lead with Credence Management Solutions. Our agenda for today: our featured use case is government agencies migration to GovCloud, migrations overview, discovery and planning, and technical deep dive using CloudEndure for migration to GovCloud. So first of all, I will provide a business context to the problem at hand, and then my colleagues Jonathan and Carlo will go into details of the technical side of the migration. First of all, who we are. Credence Management Solution, we are a solutions provider in management, consulting, program management, IT, cybersecurity, engineering, logistics, cloud, and artificial intelligence and machine learning to US federal government customers. We are based in Vienna, Virginia, right outside of Washington, DC metro area. We support the mission and goals of our customers. We provide large-scale business transformation and IT modernization support services to our federal government, Department of Defense, and federal civilian customers. We are over 1,000 professionals based in throughout the United States, and some of our employees are outside of the United States as well. So we have a worldwide presence. For some of you who may be familiar with the government contracting terminology, we are a prime contract holder on several of the contracting vehicles. For example, Army ITES 3S, OSS Small Business, Encore 3, 8A Stars, DLA Jets, which stands for J6 Enterprise Technology Services. We are an advanced level partner with AWS with government competency, and we work with AWS on multiple opportunities. Our customer, the use case that we're going to talk about today is a US government agency based in Fairfax, Virginia, which is a global enterprise located in 28 different countries with more than 26,000 employees. They manage supply chains and over 5 million items for the US federal government. Agency's contract for hosting support services was awarded to Credence as a prime in July of 2019 for $15 million, but this contract has a ceiling of $76 million, which means it has a lot of room for growth, meaning more and more workloads can be migrated to the enclave that we have set up. The customer requirements. There were 5 applications that we were originally awarded to go live with. These applications are known as EDA, PALT, PPML, CLS, and a large e-commerce application. These applications consisted of basically 200 plus virtual machines, 300 terabytes plus of data, 70 external interfaces talking to different networks. The requirement was also from a security standpoint, impact level 5. Again, for those of you who are familiar with the impact levels that US federal government has, we were supposed to migrate these applications to impact level 5 level, compliant GovCloud environments. We also were asked to help on authority to operate, which is a federal government paperwork that you have to go through for applications to go live in any new enclave. So we were supposed to put together a secure cloud computing architecture and make sure that these applications don't incur a whole lot of downtime. So by minimizing the downtime, we were supposed to migrate these applications. And we had limited or no access to source environments. So there were some challenges as we started on this project. We were asked to migrate these applications with minimal downtime. We had limited or no access to the source environments, and we were working against this very tight deadline to migrate the applications out of the current hosting providers' servers. So with that business background, I'm going to hand it over to Jonathan Trellis, who is from AWS, and he was part of this AWS professional services team that helped us in setting up the architecture in getting this process off the ground along with AWS best practices. So Jonathan, take it away.
Thank you, Atul, and thanks everybody for joining our Tech Talk today. My name is Jonathan Trellis. I'm a migration solutions architect with AWS. I was actually part of the migrations team working with Credence on this public sector migration project. I'm actually going to go over some of the migration methodologies we used during this engagement. Let's begin with some of the common migration drivers that we see with customers moving to the cloud. It used to be a very cost-centric conversation, but now it has moved to the left side, where we see it's more about increasing business agility. Some of our customers are actually creating business cases where they believe their workforce can be more productive and deliver faster as a result of migrating their skills and applications to the cloud. We still see a lot of data center consolidation projects, especially in public sector, that's driven by hardware or software end of life or end of support. Now, with cloud architectures, we actually have the advantage and flexibility to improve the security posture of applications and operational resilience. There are also customers looking to completely revamp their business using modern technologies as part of a larger transformation effort. And that's where we see a lot of solutions with IoT and AI/ML. Now, there are three main phases in our approach to large-scale migrations. An assessment phase is where we develop a business case and perform a cloud readiness assessment. The mobilize phase is where we develop an AWS architecture, a migration plan, and therefore mobilize the business to migrate at scale. And lastly, the migrate and modernize phase is where we move applications to AWS, but we also develop a cloud operating model to run and optimize the applications post-migration. Here's a more detailed slide that goes over the migration journey our customers usually see. Starts with a migration assessment phase that includes an MRA, or migration readiness assessment, along with a rapid discovery to create a TCO model to build business justification for the migration project. The MRA establishes the customer's readiness based on the AWS Cloud Adoption Framework, or CAF, comprised of business, people, governance, platform security, and operations perspectives. The second phase is mobilize, designed to build capabilities and experience on how easy it is to migrate to AWS. The mobilize phase includes 8 work streams depicted here, and the level of activity required in these work streams established by the readiness level determined during the MRA process. Lastly, the migrate and modernize phase includes actual migrations of applications that could take from weeks to months depending on the complexity and number of migration waves. Our AWS professional services team or migration delivery partners can actually prepare and work side by side with customers in large-scale migrations, operation and optimization of cloud environments and applications. Like we said before, the mobilize stage brings the tools, expertise, and migration resources together to develop a solid migration readiness and accelerate migrations to the cloud. Today, we'll just concentrate on 2 of the work streams that we did during this engagement with this public sector customer, discovery and planning, and also the migration plan. The discovery and planning workstream is where we analyze the application portfolio using discovery tools, or we can also do a manual discovery to define target migration and application patterns or migration grouping. We have to understand the details of the current environment, including where the data is. And we don't deal with just application data, but also operational data and how it is used. It is critical to know all those pieces of information. AWS and our partners, we offer a collection of tools to help customers make better decisions for architecture, modernization, migration planning, by discovering the current environment, dependencies, and identifying where the gaps could be that need to be addressed before the migration takes place. One critical aspect of developing a migration strategy is to collect the application data and rationalize it into what we know as the 7 Rs, as you can see on the right. So let's quickly go over some of the migration patterns that we offer. The 7 R's of migration is a method that we use for categorizing what's in the environment, interdependencies, and also each application's technical complexity and business criticality. Determining the application migration pattern is a critical step to the success of the migration planning and execution. There are times that the desire to go straight to an all-in refactoring of applications to take advantage of cloud-native services could result in lengthy design or application rewrite processes. That's where we see lift and shift or rehost opportunities more beneficial to get the cloud migration moving, gain some cloud experience, and also see cost savings quickly. Like Atul mentioned before, we had a tight deadline and limited to no access to the source environments to be migrated. That's why a rehost approach was more suitable for this customer. We actually migrated more than 200 VMs. I think it was over 300 terabytes of data overall, supporting 5 government applications, and we use CloudEndure to complete those migrations. We'll get into how CloudEndure works and a brief demo as well later in the presentation. But one point I want to make is that after the workloads or applications are migrated through lift and shift, it doesn't mean that we have to continue operating that way. Applications can be later refactored after customers have gained more cloud experience, especially about application performance in the cloud. And we always continue to harvest learnings from different migration projects so that we can accelerate customers through commonly encountered migration scenarios using prescriptive guidance and also best practices. A traditional IT portfolio can contain hundreds of data elements. These data elements can be categorized as application, server, network, and storage data. So let's walk through a few data elements and see why they're required. So for application data, as you can see on the left, criticality will determine the priority of applications in the migration backlog according to business and technology drivers. The characteristics define the application behaviors such as stateful, stateless, or whether an application is resumable in case of interruption. Stack will determine the grouping of applications or migration waves. For example, a group supporting an application stack, like a web server, a backend application, and a MySQL database that form a 3-tier traditional application. The server data is pretty straightforward. We deal with operating system, CPU, RAM, and disk to determine the instance type when the resources get moved to the cloud. Network data is important to map, firewall rules and also ACLs to make sure that we establish the right NACLs and security groups in the cloud. Lastly, for storage, the capacity and utilization of data. It's important to be inventorying that to identify the resource capacity planning during the migration process. From the data collected, we can extract key pieces of information to form a migration plan. Connections is a critical piece. It helps in determining application and server dependencies and also help identify access patterns. Performance metrics is another factor to help with the right sizing of resources in the cloud. And then another aspect is using service naming conventions, tags, or other host metadata to help identify patterns and group servers and applications for migration. In the migration planning stage, we help customers move the first few applications into production. We plan to deliver the migration at scale. An overall migration plan is created, including project plans, cost estimates, communication plans, and change management plans. This is where we also specify the migration approach that we talked about before with the 7 Rs, whether a system is going to be rehosted or refactored during migration. Also, the migration waves based on discovery and analysis. And lastly, the migration solution to be used during the migration process, whether that's going to be SMS, CloudEndure. For this migration project with Credence, like I said before, we use CloudEndure. But for collaboration, we leveraged Confluence and Jira to document the information collected during discovery and planning, as well as assigning tasks to resources during the assess, mobilize, and migrate phases of this engagement. Now, due to the sensitivity of data, we had to migrate these government applications to AWS GovCloud regions. We have 2 AWS GovCloud regions, US East and US West, designed to host sensitive data and regulated workloads in the cloud. Network data and compute resources are isolated from all standard AWS commercial regions. GovCloud also features a separate identity and access management stack with unique credentials that only work with GovCloud regions in a dedicated management console. The AWS GovCloud infrastructure helps customers meet a range of compliance requirements, including FedRAMP and the DoD SRG, or Security Requirements Guide, for Impact Level 4 and 5. We'll get into what the impact levels mean in a little bit, but the government applications that we had to migrate had to comply with something that's called the Secure Cloud Computing Architecture, or SCCA, framework that's outlined by the DoD SRG. So here are the cloud security information impact levels that I was referencing before. They're actually defined by a combination of the sensitivity or confidentiality of that level of information, whether that's public, private, or classified, to be stored and processed in the cloud. And also the potential impact of an event that could result in the loss of that confidentiality, integrity, or availability of that information. Like Atul mentioned before, the requirement was to migrate the systems as impact level 5. So we had to implement higher level of protection. And Carla will actually go over the SCCA impact level 5 environment and also the compliant landing zone we had to deploy more in detail in a few minutes. I just want to take a few minutes to baseline everyone on what these SCCA functional requirements mean. The SCCA is a framework to provide mission owners with guidance when architecting workloads in the cloud to meet security, regulations, and policies. The SCCA overall provides a good foundation based on best practices, but there is some implementation flexibility to make architecture changes to meet application requirements. So I want to make sure that's clear. We have some flexibility to make changes as needed. Now let's go over some of the functional requirements of the SCCA. The VDSS, or Virtual Data Center Security Stack, provides network application security capabilities within the cloud environment. So this is supposed to be something that provides application security, usually inline security, but it can extend to other things like endpoint security. The VDMS, or Virtual Data Center Management Stack, is meant to be a common environment for shared services, more of a one-to-many capability through a consolidation of Active Directory, patching, DNS, NTP, SMTP. So those kind of management services can be integrated into a VDMS environment. The next thing is the TCCM, or Trusted Cloud Credential Manager. That's meant to provide policies for controlling privileged access to cloud environments. So the goal here is, as government customers move away from data centers, like we said before, is to provide governance for software-defined resources. In AWS specifically, resources are actually software defined through the use of VPC and the AWS Management Console. So if we look at the routes and security groups and ACLs, these can be changed with the right access very quickly. So it is important to have a good TCCM plan in place. The last functional requirement is CAP, or Cloud Access Point, and that's meant to provide mission owners with dedicated connectivity to approved Impact Level 4 and 5 cloud service providers, and to also protect the Defense Information System Network, or the ISN. During the engagement with this government agency, we faced a few migration challenges, like limited to no access to the source environments, diverse infrastructures and operating system types, and complex databases with heavy transactions. Also, these applications had to be migrated to AWS GovCloud with minimal downtime. So CloudEndure gave us the flexibility to migrate from any source into AWS. For this particular project, we migrated from 2 different source environments. We did an AWS commercial to GovCloud migration, and also a VMware data center to AWS GovCloud. CloudEndure offers block-level replication support, which means a wide range of operating systems and databases are supported, as long as the replication occurs at the block level. The solution is also reliable because it provides a non-disruptive continuous replication between source and destination environments. Since we're dealing with continuous replication, cutover windows are possible with minimal downtime. And lastly, the replicated data with CloudEndure is encrypted and compressed when transferred over, so it is secure for regulated environments. So like we said before, since CloudEndure offers block-level replication support, that means that we can support a wide range of operating systems and databases, whether that resource is virtual or physical. Now let's look into a typical migration workflow with CloudEndure at the high level. CloudEndure is agent-based, so the agents need to be installed on the source servers to be migrated, whether that is a Windows or Linux machine. The replication starts as soon as the agents are installed, and CloudEndure starts moving the data into the staging area, which is hosted in the AWS platform. While the replication takes place, we can start setting up the blueprints, which will define how the target environment is going to look like in terms of compute and storage. We can test the blueprints during the test cutover phase in case modifications are required with any of the configurations. And finally, a final cutover can be performed when the workloads are ready to be migrated. So let's review how CloudEndure works. CloudEndure continuously replicates any application or database from any source into AWS. This allows rapid self-service migrations with no disruptions. The CloudEndure solution has three main components: the CloudEndure SaaS user console that we can see at the top of the slide, also a lightweight agent that performs the replication duties. The agent is non-intrusive and can be installed with no reboots. We can also automate the installation of the agent with any system management or software distribution tool. The staging area that we can see in the middle is low cost, consistent of replication servers that are EC2 instances with magnetic EBS volumes to keep the cost low. As I mentioned before, CloudEndure provides the flexibility to test multiple times to ensure that the blueprint configurations are actually correct. In case the blueprint is incorrect, we can always go back and correct it so we can retest. Once the initial replication is completed, the CloudEndure agent will maintain the continuous replication status to that staging area, and that's going to give us the flexibility to recover if we need to within seconds. CloudEndure will also launch the target production environment, which is here on the right. Within minutes. So that includes, any production EBS volume or EC2 instance, network configuration, etc. The configuration of those production resources are based on the blueprint that we talked about before. When we're ready to cut over, CloudEndure will perform automated machine conversions, and that includes any kind of bootloader changes or hypervisor driver injections and so on. Let's review some of the network configuration requirements for CloudEndure. The connectivity from the source environment here on the right, which could be any data center or cloud environment, to the CloudEndure user console, needs to be done through port 443 HTTPS. And that's for any connectivity to the console, whether that's from the source environment or the staging area here in the middle, which will be the replication servers here initiating the communication to the console through port 443. All the replication traffic between the source environments to the target cloud environments are done through port 1500. For this government customer, we used a combination of direct connects and a private subnet to replicate the resources to AWS GovCloud. The data in transit here is also encrypted with AES 256. Now, the staging area and target environments here on the right, they can reside in different subnets, different VPCs, and now different AWS accounts. CloudEndure now supports hosting replication servers in one AWS account. So the actual staging area here can be hosted in one account, while we launch the production or target servers in a different account. That's a good benefit or feature now for public sector customers because of compliance requirements like the SCCA that we talked about before that recommends the isolation of AWS accounts and environments. All right, so I'm going to go into a demo and show you how CloudEndure works. So here's the CloudEndure user console. Here on the upper left, we can get access to all of our migration projects. We can also add new projects if we need to. Let's go over setting up a project so we can kind of see the configurations needed to get that done. After the project is created, we need to provide credentials to the staging and target environments. Let me go back to the visual here. So like we said before, the staged environment has the replication servers that facilitate the replication from source to target environments. And then the target environment will host our production servers here on the right. So we can use different credentials, host the environments in different accounts, or we can use the same credentials for both environments. So the migration project here simulates an on-premise migration to GovCloud. We selected other infrastructure as the migration source, and the migration target is GovCloud West. We can also configure replication server configurations, the replication server size, the subnet, security group. Just to go back to the visual here, this is what we're actually working on. The replication server size and also the VPC and subnets and security groups that these servers are going to be using to facilitate the replication between source and target environments. We can also use VPN or direct connect, and that's actually what we did for this public sector customer, a combination of direct connect and a private subnet. We can also tag resources the CloudEndure is going to deploy for replication traffic in case we need to identify that. And lastly, we can also get notifications for this project in case we start replication for resources. We can get notifications on that, so that can be configured on this page here. So here's the machines page where we can track the data replication status of the servers to be migrated. So let's go over how to install the CloudEndure agent. To add more servers to this project, we'll have to go into Machine Actions and then Add Machines. So we're actually going to get an installation token for this particular project and also instructions on how to install this for Linux and Windows servers. So for the demo today, we have two web servers hosting a static application running on Windows. So we're going to copy and paste the command to install the CloudEndure agent on Windows with the installation token as well for this project. So we copy this, and then let me log on to web server 2 because web server 1 is already replicating, and we'll get into the configuration of this in a minute. So let me go back to machines and then log into web server 2. Okay, so I'm already there. I placed the installer file in the documents directory. So let me actually browse to that. And the user is demo user, documents. Okay, so now I can copy and paste the installer. So it's the exe that's placed here in the documents with the installation token. So let me go ahead and run that real quick. And while the agent is installing, we have other options or arguments to install this. Let me quickly go over the documentation as well. So here we can see that we have additional options to install the CloudEndure agent. For instance, we can specify that the replication doesn't start right away. We can force certain volumes on the servers and so on. So our documentation is pretty detailed to go over those arguments. Let me go back to the web server and yep, there it is. So the agent is already installed. So let's go to the CloudEndure console to look at the replication status. So let me open my browser window, and there it is. So web server 2 is already replicating. It's at 22%, and the ETA for full replication is 19 minutes. So if we go back to the machines page, we can see the status of both web servers. Like I said before, the installation of CloudEndure can be also automated through a software distribution tool, so we don't have to run the same manual process that we did today to install the agents. Now, if we look at web server 1, we can see that it's doing continuous data replication, but there is a notification that the server hasn't been tested. So the goal here is to test our configurations before we do a final cutover. So we'll be doing a test cutover from the staging environment here in the middle to the target environment. And we can do this multiple times to ensure that the blueprints are actually correct. And then when we're ready, we can do a final cutover of the server. So let me log into web server 1 to see the actual application. So it's running IIS. So let's open that real quick and then go into the actual website and browse to it. So as we can see, it's running a simple static page running on port 80. And that's the application that we're going to be migrating to GovCloud. We're going to be making some modifications to the code base to ensure that whatever changes we make at the on-premise environment can replicate to GovCloud. All right, so let's go back to the CloudEndure console to look at the server configuration. So this is web server 1. If we look at source, we can see that we get all the information from the source environment. So we get the DNS name of the server, we get the CPU type, operating system, number of disks, and also the installed applications on that server, as well as the running services. So that's pretty important for us to identify the actual state of that server before it gets migrated. So that's pretty useful information there. Let's get into the blueprint so we can go over that as well. So the blueprint configurations will specify the final state of my web servers. So I can specify the server size, or I can let CloudEndure decide. So I'm just going to go and select the server size. Let's make it T3 small. And then I already have a subnet already created for this environment with the appropriate security groups for port 80 and 443. So I'll just pick that. We'll leave the private IP the same, and we'll choose a elastic IP from the environment. So let's do existing IP address and select one of them. You can keep going down, and I can also tag the resources. So we can easily identify them after we deploy them. So I'll save that blueprint. And now we're ready to do a test deployment of that server. So for that, we'll need to go to launch target machine. And like I said before, we can do a test cutover or a final one. For this particular demo, let's go ahead and do a test. And then continue. And we can actually monitor the status of that test deployment if we actually go into the progress of that job. Now, the goal here is just to go back to the visual. Let me erase this. Is to actually do a cutover test from the staging area, which has the current state of that server being replicated, into the target production environment. Since I already have the security groups already configured, I should be able to hit the application here that's being migrated to GovCloud by this particular address on port 80. So we'll test that in a minute. If we go back to the machines page, we can see that the test cutover for web server 1 is complete. So again, let's go ahead and grab that IP address so we can test the application that's already in GovCloud through port 80. So let me open up a new tab, and the IP is 160.1.58.185. And let's see, and yep, we can see that the application has been migrated successfully and running in GovCloud. We can set up a DNS record if we need to, put in a certificate to make the website listen on port 443. But as we can see, the actual page is already running in GovCloud. So let's go back and log on to the on-premise web server. We're going to make a final release to this application. So let me browse to the inetpub directory and make a quick edit on index.html. And let's rename this to final production environment. Do a quick save, and let's browse that page. So the on-premise environment has the new release that says final production environment and the name of our tech talk below that. So if I go back to the GovCloud application, it should have the previous state when we did that test cutover. So the goal now is to replicate the change that we just made on that web server to the GovCloud environment. To make that happen, we need to go into CloudEndure, go back to our web server 1, select it, and then launch a final cutover. And then continue. And then we'll wait until this is done, and we'll go back to this, refresh the page, and we should be able to get the latest changes that we published on the source on-premise environment replicated to GovCloud. So let's check on the status of that final cutover that we did. So let's log back into the CloudEndure console, click on our web server, and we can see that the cutover was completed successfully. So we should be able to go back to GovCloud and do a refresh on this page, and this should be changing to final production environment. So let's go ahead and test that now. And there it is. The change has been published to GovCloud. So this demo shows how simple it is to do migrations with CloudEndure. I'm going to pass it over to Carlo now. He'll do a technical deep dive into how we accomplished this government agency migration project.
Hello, my name is Carlo Tedesco, and I'm the technical lead from Credence Management Solutions on this project.
Before migrating workloads with CloudEndure, there are several technical preparations that you should take. First, develop the list of instances to be migrated. Know your source and target IPs and your IP ranges. You need to create the firewall rule exceptions. You need to build out your target environments. And you need to acquire proper permissions to install agents on source instances.
Here you can see an example of our SCCA compliant environment that we've built out and where we are now hosting these workloads. Here you can see our VDSS, our virtual data security services. This is where all of the traffic comes through into our environment and is monitored. Our VDMS, or virtual data management services. This is where all of our services for the environment live. Things that are required from an SCCA compliance guideline, antivirus, STIG compliance, scanning, Active Directory, and so on. Down here, you can see all of our tenant environments. Every tenant is separated into its own VPC, which is also contained within its own AWS account. Here is the CAP. This is our direct connect to the DISA NIPR network. And here is our transit gateway, how we connect everything and route everything and control traffic through our environment and isolate the different workloads. In order to mitigate the risk that we foresaw when taking on this challenge, we came up with two proofs of concept in order to prove out certain things that we had questions. One, would CloudEndure be able to migrate into GovCloud? And then two, were we able to use CloudEndure to migrate through the NIPRnet? So our first proof of concept that we did is we migrated 18 instances from a commercial AWS environment into our GovCloud environment through public internet. Obviously, we were successful. And then the second one is where we migrated 2 instances from the actual source environment through the NIPRnet into our GovCloud SCCA compliant environment. And again, we had success with that proof of concept as well. So some challenges that came about because of the SCCA compliant architecture and the way the accounts structure was set up. CloudEndure was not really set up at the time to be able to launch the workloads into the end state environment. It was set up that it assumed that the end state environment was the account that we replicated into. But because we had to replicate into VDSS, which was one account, and then the final target environment was in a separate account because of our SCCA compliant architecture, we actually had to move the workloads after we replicated into a VDSS where we staged them, and then we moved the entire workload into the final target resting place. This caused, so we had to come up with our own tools in order to move the workloads using CloudFormation and some other tools like Python in order to do that, and it was successful. But as an update to that, because of this challenge that we had, the CloudEndure team actually created a feature where you can now launch from the staged environment into a separate account, which solves this issue. The other issue that made was that we were duplicating resources in 2 different accounts, and we ended up with more costs than necessary, which is that's also mitigated now that CloudEndure allows you to launch into a separate account. So kudos to the CloudEndure team to find a solution and get it implemented. Some other challenges, we were migrating very large instances up to 15 terabytes of EBS volume. The challenge here was that if that replication was interrupted, then we would have to do a rescan of the entire instance, which could take several days. So in order to mitigate this, we avoided rebooting the source instance while we were doing the replication. And this allowed us to not experience a rescan, and we didn't have to re-replicate the entire instance. Managing connections through firewalls. In the DoD environment, there's a lot of silo and segregation of networks. So it was a challenge to locate all of those points where we had to request firewall rule exceptions to make a clear pathway from the source environment to our environment. We designated 1 or 2 people to own this task and really see it through end to end. And we did experience great success in doing that. Finally, the configuration of some source instances led to bottlenecks with IOPS, and this caused us to experience very slow replication in certain areas. We got creative here, and we packaged up those servers and used other servers that were replicating pretty quickly as courier servers. We would package up the different LVMs, zip them up, and stick them on other replicating servers, and then unpack them on the other end in our environment and rebuild the server manually. 2 last challenges. Limits in EC2 instance types in the target accounts. You have to make sure that we request those limits early so that we don't run into those. And one of the applications was on an older version of a Linux operating system, which caused us to have to limit the type of instance that we were using in the target environment. So being aware of those limitations is also key. So as you can see, we completed our migration in 138 days, and it was about 6 weeks ahead of schedule despite all of our challenges. This goes to show the determination of our team and their ability to see complex problems and use creative thinking in order to accomplish our goals. We used 11 waves total. The largest instance was 15 terabytes of EBS volumes, as I said previously. We averaged about 450 gigabits per second per instance when we were doing replication through the NIPRNet. And then we met all of our security requirements with minimal downtime. This experience has produced many lessons learned that we have come up with some best practices that we'd like to share. Request limit increases early, request firewall rule changes early, basically try to anticipate these challenges and do what you can to mitigate them early on. Use security groups to limit exposure of the target environment. This is a standard practice. Limit number of instances per wave. This way, it allows you to closely monitor each instance to make sure that there aren't any problems being missed or errors or challenges that aren't being accounted for. Use bootstrapping to clean up the legacy processes on the instance. CloudEndure allows you to create a bootstrap that you can implement on the source side, which will fire on the target side when you launch the instance. This allows you to remove a lot of legacy processes from the source environment, such as backup processes, antivirus processes, Active Directory configurations, etc., and automatically removing these things as they come up in the new target environment, and also installing those new processes in your environment as well. Lastly, removing CloudEndure agents from the target environments once they're fully launched in the new target environment.
Thank you, Carlo. Well, let's go over some final points. Thanks to CloudEndure's ease of use and our AWS assess, mobilize, and migrate phases that we actually went over during this presentation, the team was able to complete the migration projects rapidly and efficiently. The government systems that we migrated to GovCloud were very complex, so we required significant level of effort during the discovery and migration planning stages. That's why today we kind of concentrated on 2 out of the 8 work streams that we typically see during a migration. Our team also, with Credence, worked on delivering a solid business case for migration, putting together a CCOE team, getting experience through our pilot migrations that Carlo was mentioning before, and also building a secured SCCA compliant environment in GovCloud with a good operating model. We were also able to migrate a wide range of technologies with CloudEndure, like Apache web servers, IBM, DB2, and MySQL databases. We also had some Windows, remote desktop, and Active Directory servers, and so on. So the flexibility of using Direct Connect with CloudEndure, and also being able to encrypt the replicated traffic from source to destination environments made the implementation of CloudEndure suitable for this government customer. We also received great feedback from the user community after the applications were migrated to GovCloud. Finally, through our professional services engagement, we enabled Credence to develop a solid migration delivery practice. Credence was able to gain customer confidence and continue to work on mission-critical application migrations. So we look forward to more successful public sector migrations from Credence. Well, thanks everyone for joining our Tech Talk today. For more information, you can reach out to Credence Management Solutions, our GovCloud and CloudEndure teams. Have a great day.